Okay, so here we go. No more bad stuff. First one is T. Next one here, I don't have the option of speed, but all I do have the option is V for velocity. The next one here is going to be distance for the direction. How far is distance or displacement? I think somebody in this class asked, was distance the same thing as displacement? That was a really good question. Yes, it is. Now, don't forget, though, displacement is a vector that does have direction, but we didn't have that option here. The next one is acceleration. The next one is velocity. How long did it take is T for time, and how high up is the distance or displacement. Then this one over here was actually kind of tricky. So for those of you who did do it, you may have got it wrong, and I apologize if that's the case. But it says here, what is actually missing from the list? When you look at the list, what is actually missing is time. Time is not even on the list. It's actually missing. And since time is missing, we go back to our flow chart that we have memorized now. Was D ever talked about, used, discussed, or given? Yes, it is. Right here, it's my unknown. Well, what about T? No, it's not. My equation is A equals VF squared minus VI squared over 2D. So I apologize if you got it wrong, but that's what they were asking you. What is truly missing in the list? The next one, they shuffled it up and changed it a little bit. And they said, okay, in this case now, what is missing over here? And what am I missing here is the VI. VI is actually missing. Now, when I go through my flow chart says, was distance ever used? Yes. Was T ever used? Yes. And since T and D was given to me, my equation should be D equals VI times T plus 1/2 AT squared. Okay? Now, my question, though, is, remember, before I say Jesus take the wheel, I've got to ask, is my will okay? And actually, when I come over here, I'm actually question mark the distance, and I was never given to me. So in this case, that equation is not the correct one. But we know from our flow chart, if this is not going to be used, then we're going to come over here and say D equals VF times T minus 1/2 AT squared. Jamie, you having a heart attack? I'm sorry. And I don't know CPR. That's the reason why I said sorry. For heart attacks? I don't let them die. That's what
heart attack.
No, they're different. Heart attack is like when your heart is beating abnormally fast. Cardiac arrest is it stops.
Well, what do you do when you get a heart attack?
I don't know. Go to the doctor. Shock it.
Shock.
That's what the little shock thing in the corner is.
I've never had.
I've never had it.
Okay,
Did y'all not do the training before this?
What training?
for the heart attack?
No.
No.
There's a training for CPR. I forgot.
Oh. Okay, hold up. Micah, remember that. That's pretty awesome. Jonathan, that was low. Okay, you're cold-blooded over there. Let's keep going, because Ashlyn feels like she is legit here.
No, I turned it in. It's not in my back.
All right, we're gonna come back to that in a moment, Micah. Later on, don't stress out on it. Seriously, don't stress on it. The next one over here, what's missing from the list? Hopefully, we all got that the distance was missing from the list. But in that case, my question says, was distance ever used, talked about, discussed? No. So A equals VF minus VI over T, and that is the correct equation. The only one I think we might have missed was this one. Let's go ahead and go back over here to this other side. We're still thinking kinematics. So if a person goes down a swimming pool and comes back after 20 meters there and 20 meters back, their displacement is 0 meters. Now, if a rock falls 15 meters, well, then it says here, is this a vertical or horizontal motion? And the reason why is because we're slowly easing into what we call parabolic trajectories. And in this case, if it falls downward, it is a vertical direction. Now, the displacement of the rock is a negative displacement because it's going downward. Now, a car is moving 12 meters per second and stops. The final velocity is 0 meters per second. And if you throw a rock into the air and catch it, its displacement is 0 meters. Okay, we're going back to kinematics. That's exactly what we're going to look at today. Number 7. I'm sure that most of us got these right, but I'm going to show you the last one. Oh, I think I got some of you on the last one. Let's look at number 7, though. It says here, 10 seconds. In 10 seconds, a car accelerates. So the t is 10, the acceleration is 4. That means they speed up. The final velocity was 60. My initial velocity is my unknown, and distance was never given to me. Okay? Now, before I even start to do the math, if this is a positive acceleration, and this is my final velocity, my initial velocity better be slower because I sped up. So my answer for VI better be less than 60. Do you see what I'm saying? We need to start critical thinking before we even do the math. Now, if distance was never used, talked about, or discussed, A equals VF minus VI over T. Plug in your numbers when you do that, then VI actually comes out to 20 meters per second when you do the math. So it comes out perfect. The math works just right for us, and you should have got the correct answer of 20, okay? The correct answer of 20. The next question over here, though, says that an object moves 2 meters per second, okay? So 2 meters per second is a velocity, VI or VF, and an acceleration of 3. So I've got 3. I know that the t is 8. My initial velocity is 2. It starts to accelerate, so my final velocity was never given to me, but how far did it travel was my unknown. So was distance ever used, talked about, discussed, or given? Yes, it's my unknown. Was t ever used? Yes. D equals VI times t plus 1/2 AT squared. So that's my equation. Before I go any further, I want to double check if this is a good equation. Distance, question mark. VI, check. T, check. 1/2, check. A, check, and T, check. Not only is it good, but my equation is set up the correct way, so I don't even have to rearrange it. In this case, distance equals 2. Multiply it by 8 plus 0.5 times A, which is 3, and T is 8 squared. Distance equals 16 plus 96, or the distance is 112 meters. So hopefully you checked your answer. Oscar, are you getting it though? Seriously, deep down inside in your gut? Do you feel like you're understanding it a little bit better? Then,
This one, yeah.
yeah, compared to,
Started with 12.
okay. Oh, 12.
I
Ooh.
think I got it right.
Okay, okay. So stop for a moment and just think about 2 or 3 weeks ago when we first started talking about this. Hopefully now y'all feel so much better than you did 3 weeks ago. It should be really, like, your math skills should be coming along. The next one says that an object at rest, okay, initial velocity is 0. An object at rest. Tells me there that it reaches a distance of 40 meters, and it's going at a velocity or a final velocity of 20 meters per second. What is the acceleration? T was never given to me. So was distance ever used? Yes. Was t ever used? No. A equals VF squared minus VI squared over 2D. Okay? Let's double check it to make sure that this is a good equation. A is my question mark, VF check, VI check, 2 check, and distance check. So in this case, not only is it good, but I don't need to rearrange it. So A equals 40 squared minus 0 squared over 2 times, oops, I messed up, didn't I? 20 squared and 40's distance. So 0 squared, take away 0, get that out of there. 20 squared, we do that. 20 squared, do I have that? How much is it? 400? A equals 400 over 80. 400 divided by 80 is 5 meters per second squared. So double check your math, make sure you got the same thing, give or take. Definitely make sure you got the same equation. I do want to stop for a moment and make sure that we all know that there's more than one way to do this. So if you did it a different way and still got the same answer, you're awesome. The next one, a rocket climbs 200 meters in 4 seconds. Now, if it was moving 10 meters per second to begin with, what is the final velocity? Question mark. My T is 4, my A was never given to me, my VI is 10, and my distance is 200. Was distance ever used, talked about, or discussed? Yes. What about T? Yes. D equals VI times T plus 1/2 AT squared. Check it to make sure this is correct. D, check. VI, check. T, check. 1/2. A, not given to me, and T is checked. Aiden, my question to you is, first thing is, could you use this equation itself? Like, is this a usable equation? Could I solve this equation? Not saying this is the equation I want. Could I use this equation? Yes, I could. Now, Jamie, am I looking for A? I'm not. So I'm not saying that this is not the correct steps. I am going to use this equation. I'm going to solve for A, plug it in, and then I will solve for the VF. So even though my flow chart says use this, it's just guiding me to a 2-step problem. So I'm going to go ahead and I'm going to use this, say 200 equals 10, multiply that by 4, plus 0.5, multiply that by A, which I don't know, times 4 squared. 200 equals 40 plus, I got 8A, subtract 40, 160 equals 8A, divide by 8, A equals 20. Not my answer, that's only step 1. Step 2, I'm going to use A equals VF minus VI over T. Now I have my A, I have my VI, and I have my T. I can solve for my actual answer, which is my VF. So in this case, A, which is 20, equals my VF, I don't know, minus 10 over T. Okay? Now, before I solve this, I need us to start thinking, again, logically, before I plug things in. If my A is a positive number of 20, Eric, my VI needs to be greater than or less than my VF. How should it be? Does that make sense? No? Okay. My acceleration came out to 20. Is it a positive 20 or a negative 20? Positive means that I'm accelerating. So we need to kind of start thinking about my initial velocity and my final velocity. I'm actually looking for my final velocity. My initial velocity is 10. So my final velocity should be bigger or smaller? Should be bigger. Right, because my A is not negative, it's a positive A, then my final velocity should be bigger than my initial velocity. So kind of start brainstorming before you even do this, but when you do this, VF actually comes out to 90 meters per second. So, bam, I'm already moving in the right direction. Number 11, because I really like 12. Really like 12. 12 is a tricky question. Number 11, it says here that a car actually comes to a stop. Okay, VF is 0. They also tell me that it moves at a distance of 120. They gave me the A of a -5. -5 means that I'm slowing down. I'm coming to a stop, which makes sense because my VF is 0, my VI better be bigger than 0 because I'm coming to a stop. They also tell me that my distance, was 120. My T is question mark. The VI was never given to me. Okay, let's go through the flow chart. Was distance ever used, talked about, discussed? Yes. T, yes. In this case, then, distance equals VI times T plus 1/2 AT squared. Stop and check it, though, Oscar. Do I have a distance, yes or no?
Yes.
Do I have a VI?
No.
Do I have a T?
Yeah, no. That's what we're looking for.
That's what I'm looking for. I've got to pause. I know algebraically I can't solve anything where I'm missing two variables. So in this case, Aiden, what do I need to do with the VI? Uh-huh.
Oh, you need to change it to the VI.
There you
And
go.
You have to change the sign.
There you go. I agree 100%. There you go. I agree 100%. So in that case, now I need to change that VI to a VF and flip that positive to a negative sign, exactly like that. You're going to go ahead and do your math. You find that your T equals 6.9 seconds. But number 12, let me read 12 to you because some of you did the math. Jamie, did you do the math? Okay.
What did you get, Aiden?
On number 12? What'd you get, Aiden? 10, what'd you get? Did you do 12?
What did you get, Hector?
Did you, whoa, Hector, did you mathematically do it? Did you got a negative 10? Oh. What?
Because it is negative because it's dropping down.
Oh.
I mean, the answer is
Guess
right.
what? I didn't even do the math.
Oh, it's negative
Ah!
9.81. You suck.
Boom!
my.
I'm gonna take that as a compliment. Dang! Hold up.
As soon as you said I didn't even do it mathematically.
Boom! That's because I'm the teacher. An object drops. Hold up, wait a minute. Drops off of a cliff. What is the acceleration?
Negative 9.8.
Done. Which is 10.
Yeah, like if you round it.
If you round it, it comes out to 10. I didn't even need to do the math. Negative 9.81. Let me get you on the test.
Negative 9.81.
Negative 9.81. I'll take negative 10. Mathematically, when you work it out, it comes out to a negative 10. But negative 9.81 is close. I would have took any answer. I'm just saying that I need to work smarter in my brain because how long is it taking y'all to take these tests and quizzes? Not too long? Some of y'all it's taking too long.
It's taking me too.
It's taking you too long. Seriously, I don't want to say, I'm going to say it right now. Ashlyn, it's taking him too long to take the quiz
It's not
and
every class,
test.
It's every class.
It's every class. Yes. But we're not going to show her. Okay. Because of test security. She just called. She said she's sick.
Where is she now?
Just pause it.
Oh, I don't know.
She's sick.
Maybe she's got strep throat. I don't know. Okay, we're talking about her and she's being videoed. Can we not talk about her while we're videoing it for her?
Okay, stop the video, and then we can talk about it.
No, then I have to like do two different videos and it's,
Just mute it.
Oh, yeah, you could just pause it.
Yeah.
oh, y'all are so smart. Y'all are so smart. Talk to me after class though, don't leave today. Okay, all right, so here we go. We ended up with our notes over here talking about the hummingbird, all right? We talked about the hummingbird, and we did our Pythagorean, and we did our SOHCAHTOA, and we combined everything together for this equation. Now, and this is, hold up, when do we do Pythagorean and SOHCAHTOA? When we have a right angle on a triangle. When we have a 90-degree right triangle, we Pythagorean and SOHCAHTOA. Okay? But what if you don't have a right angle, which is what we're getting today?
Change the story up.
Gotta do what you gotta do sometimes when you're just put in a situation. I hear you. I hear you. So in this case, we don't have a right angle, okay? We're gonna start talking about this word projectile motion today. And projectile motion is when there is not a right angle and actually you have an object that's floating through the air, okay? And when an object is floating through the air and is going to land, you do kinematics, okay? But there's a problem. When I throw an object, oh, hold up, I got something to throw. Oh? Yeah, somebody snuck out with my pencil. but they were honest enough to bring it. So when I throw an object, wait, real quick. When I throw it, throw it. Okay, whoa. Did you see how it went? It went like this. Don't make it so high. Whoa, look where I caught it. That's because I'm a baseball mom. Okay, I'm good. Look, did y'all see me catch it down here? You scared? He was like, ouch! You okay? I've never seen no one do that. Oscar, catch. Did y'all see that? It does this. Okay, it does this. Not only is it going sideways, it's also going what direction? Which is the sideways, I agree. Not only is it going horizontal sideways, it's also going down. I had to catch it, y'all. It came over here and y'all caught it like this, right? It's going sideways and it's going down at the same time. So, when we have an object in projectile motion, I know that was really funny. We needed to. Hold up, let's see. Ashlyn, say hi to everybody. There we go. I know, I feel bad for her. She needed to see everybody. Okay. Here we go. So projectile motion is motion of an object moving in two directions. You just saw that. It went sideways and it was falling down while it was going sideways. Right? And when it does that, those two directions are what we call in physics the X and the Y direction. Y, which is up and down, and X is sideways. Okay, so objects that are thrown or launched into the air are subject to what? When it's thrown in the air, launched, dropped, it's subject to what? What is touching it? There you go. Gravity. And those objects are called projectiles. An example is like an arrow. When you pull that bow back and you release the arrow, that's a projectile. When I throw a softball, when I kick a soccer ball, when you go and play darts with somebody, you don't go and try to hit and aim at the bullseye. You got to throw it up so the arrow or the dart can come down to the bullseye. If not, you're never going to reach it. You're always going to fall and hit below. Okay? Huh? Oh, next week we're going to talk about the velocity of it going sideways on how that determines where it lands. That's next week. Okay. Projectiles follow a parabolic trajectory. That parabolic trajectory path is a curve that's called a parabola. Remember I told y'all what happens when we were younger. We were taught wrong some things, okay? Right? Now this is another thing. Wile E. Coyote. When Wile E. Coyote on that cartoon runs, he stops, and then he does what? Falls straight down. Absolutely incorrect. The only flow of a parabolic trajectory will always be a parabola shape. The only trajectory from any object that's thrown into the air, tossed into the air, or fallen is going to be a parabolic trajectory, a parabola shape. Okay? Now, we do know that here we live on planet Earth, and because of planet Earth, we have these air molecules that are going to hit objects, slow it down, and change the path. But remember, in this class, we are always going to assume that all things take a perfect parabolic trajectory because we are assuming that all of our math is going to be without air resistance that's going to slow it down. So without air resistance, a projectile headed into the air will take a perfect parabolic path. But because we do live on Earth, there's air molecules that are going to collide with it and cause it to take a shorter path than it should. Okay? Which is not that perfect, exact parabolic shape. If those of us who are going to go into aerospace technology and engineering, which some of y'all are amazing, y'all would be great at this, okay? Or mechanical engineering, okay? For those of us, please, we know that this is the true situation, but we're going to assume that that's not the case here. For the purpose,
On the moon, say you were to throw a ball, will it keep going straight forward or will it eventually go down?
Is there gravity on the moon? Because that's what causes, well, look, who has a ball?
How far would it go?
Who has a ball?
I do.
Oh,
I was gonna say.
okay. What caused that to fall? Y'all are some sissies. No. Okay, pause that. Y'all are sad. Gravity caused it to fall.
You didn't
So
fall.
there's no air resistance.
I know,
That's how it's-
she heard. So there is no air resistance. And gravity pulls how on the moon?
Towards, oh.
Stronger or less?
Less.
Less.
I thought she was asking.
So when it flows, it's gonna flow how on the moon? Number one, there's no air, and number two, gravity is smaller, it pulls less. So when you throw that ball, how,
It's just gonna.
it's gonna go, look, longer in the air.
But
than
it's
it
still
would.
gonna make a parabola.
But it's still gonna make a parabola. Yep, good question. It's still gonna make that parabola. It says here, for the purpose of this class, remember, we're going to ignore all air resistance and assume that all projectiles take a perfect parabolic path. Projectile motion, listen to this part, is like a free fall question. We've already did free fall questions. Those are kinematics. Free fall questions. I have my object before it falls. Look, it's about to fall. What are the two things that I know when it comes to a free fall questions? There are two things that I know for sure. What are the two things? Give it to me.
Acceleration is V.
The acceleration is A, is what is it?
Negative 9.8.
And what's the other thing that I know on the free fall question? Not VF, which is? Thank you. The initial velocity is 0. There are two things that I know guarantee on a free fall question. Number one, A is negative 9.81, and the VI is 0. Got to know that. It says here, though, don't forget, we will always neglect air resistance in this class. And therefore, the horizontal, because we're going to start using the words horizontal and vertical now, velocity on the x-axis, because that's sideways, horizontal, is going to be a constant number. And that will make more sense next week. So let's go ahead and let's get started on this part right here. This equation right here is going to be the horizontal equation, which is going to be on the x-axis. My equation for the horizontal direction, not the vertical, but the horizontal, because when we throw that ball, what happened? The ball was moving not only horizontally, but it was also falling down vertically. Okay? So the horizontal equation in the x direction is d sub x equals v sub x times t. So on here, this equation you've seen already, which is if you do not like looking at it this way, the other way you can look at it is, what is it, Aiden? But because we're talking about the x direction, we just want to make sure that's the reason why the sub x is there, just distinguishing that we're talking about the horizontal. So go back to that tennis ball that we were just throwing around the classroom. Whereas that tennis ball was flying horizontally, there's a velocity, there's a distance, and there's the amount of time that it was flying horizontally. And what do I do know? That the horizontal velocity in the x direction is going to always remain constant. Why do I call it constant? Because we're going to assume that there is no air that's slowing it down horizontally, okay? So the d sub x is the horizontal distance, which should be in meters. The v sub x is the horizontal velocity, which is meters per second. And the t, which stands for time, is seconds. And we've seen it before. So if you don't like looking at it this way, then look at it this way. But they're the same equation. So I'm not tossing anything new to you. I'm just using what we have, and I'm just twisting it a little bit different. Other than that, we're going to pause it here. I'm stopping because we're done with our notes at this point.